Calculate the molarity of 0.06 moles of sodium bicarbonate in 1500 milliliters of solution. So we know we have our moles, which is 0.06 moles in 1500 milliliters of solution. And we're calculating the molarity. So we know we have our moles and we have our volume, which is our liters. So we need to divide our moles by our volume. So we have our moles divided for volume. That's our formula for molarity. This guy has to be in liters though. So to change milliliters to liters, we can divide that by 1,000, which gives us 1.5, or we can move our decimal place to the left. It gives us the same number. So we have 1.5 liters of sodium bicarbonate solution. So we're going to divide our moles by our liters. And if you put that in your calculator, it would be 0.04. And it would say we have a 0.04 molar solution. Or we would use the symbol M, which is the symbol for molarity. And we would say our molarity is 0.04. And number 2, what is the molar concentration of 1 mole of potassium chloride dissolved in 750 milliliters of solution? So when we see this word molar concentration, really it's just asking for molarity. It's just a fancy word for molarity, so don't let that throw you off. And we know our molarity is moles over liters. And we have our moles, which is 1.0. And then our volume over here is 750 milliliters. And to change that to liters, which it has to be in to calculate molarity, we're going to take 750 and divide it by 1,000. So it's 0.75 liters. Or we can move the decimal place to the left 3 times. Either way, we're going to get 0.75 liters. And if we were to divide 1 mole by 0.75 liters, our answer is going to be 1.33 molar. So we would say we have a 1.33 molar solution of potassium chloride, or our molarity is 1.33. Number 3 is calculate the molarity of 29.25 grams of sodium chloride in 2 liters of solution. Now to calculate molarity, we do need moles over liters. We have our liters, but this is in grams, so we need to change that. So if we were to find out how many moles of sodium chloride we have, we would divide that by the molar mass. Now we would look at our periodic table of elements, and we would find that 1 atom of sodium has a weight of 23, and 1 atom of chlorine has a weight of 35.45. So we were to add that up, we would have 58.45 as our total weight for sodium chloride. It would say 50 in 1 mole of sodium chloride. We have 58.45 grams of sodium chloride. These units would cancel out. We would multiply these across the top and then divide by 58.45, and we would be left with 0.5 moles of sodium chloride. So now we have our moles and we have our liters, and we're just going to divide. So 0.5 moles of sodium chloride in 2 liters of sodium chloride. And if we were to put that in our calculator, our answer would be 0.25. So we would say we have a 0.25 molar solution of sodium chloride, or our molarity is 0.25. Okay, so the number 4 is calculate the molarity of 34.2 grams of sugar, C12H22O11 in 500 milliliters of solution. So we were given grams and milliliters, so we're going to have to change both of those in order to divide moles by liter, which is our formula for molarity. So if we were to change 500 milliliters to liters, we're going to divide by 1,000 or move our decimal place 3 to the left, and we would have 0.5 liters. Now, to find our moles of sugar, we're going to have to take a look at our periodic table of elements again. So we have our carbon, our hydrogen, and our oxygen. Not bad. Just a second here. Okay, so we have carbon, hydrogen, and oxygen. We have 12 carbon, 22 hydrogen, and 11 oxygen. Carbon has a weight of 12, hydrogen has a weight of 1, and oxygen has a weight of 16. So if we multiply these across, we would have 144, 22, and then oxygen would be 176. If we add those all up, we are going to have 342 grams per mole. So we have 34.2 grams of C12H22O11. And we know that 1 mole of C12H22O11 has 342 grams. We would find that if we multiply across and then divide, we find that we have 0, these cancel out of course, we have 0.1 moles of C12H22O11 or 0.1 moles of sugar. So now we have our moles and we have our liters, so we can go ahead and divide and find our molarity. So molarity equals moles over liter, so in this case it would be 0.1 mole in 0.5 liters. So our answer would be 0.2. Molar solution of sugar or C12H22O11. So we would say our molarity is 0.2. And of course that big M stands for molarity. And number 5 is calculate the number of moles of sodium chloride contained in 0.5 liters of a 1.5 molar solution. So this question is a little bit different. We're given our volume, which is 0.5 liters, and we're given our molarity, which is 1.5. So if we look here at our triangle, we are given this guy, which is our molarity, and our liters, and it says if we want to find our moles, which is up top, we just multiply the two and it will tell us how many moles. So let's do that. So if we have 1.5 moles per liter, which is our molarity, times 0.5 liters, these guys cancel out and we would have 0.75 moles of sodium chloride. And number 6 goes off of number 5. It says how many grams of sodium chloride are contained in this solution discussed in problem number 5. So if we have 0.75 moles, we know if we draw our triangle here, if we want to find the number or the grams, which is this guy right here, we take our molar mass and we multiply that by the number of moles. So to find our molar mass, we would go to the periodic table. We know that in sodium chloride, sodium has 23, the weight is 23, and chlorine is 35.5. So we have a total weight of 58.5. So we have 0.75 moles. And we know in 1 mole, we have 58.5 grams. And if we multiply those across, we're going to have approximately 44 grams of sodium chloride. So we have number 5, our moles. And if we were to take that in grams, it would be roughly 44 grams of sodium chloride.